All right, well, we'll just get started with who we have now, and uh, if needed, we can catch up a little bit later. But welcome back to Python Level 2, Class 2. Not really any announcements on my part, although I do want to talk a little bit about homework first and then review second, which is a little bit different than normal. The reason I want to do that way is because the homework submissions for this week were a little bit low. The homework is not graded exactly. I do take a look at it and I give like a score, but I always give 100. The score doesn't matter. The purpose of the homework is just to practice, like I say, an hour of class each week. It's not really enough to fully remember everything we talk about. Like, I know it's not just about you. Like, if I was there, I can't just sit through a class for an hour and then remember it for a whole week. It does slip away if you don't practice it. So that's the point of the homework. And that's why I really want as many people to do it as they can. I know everyone can forget, and that's perfectly fine. But please try to find the time to do the homework for this week. And if you ever get stuck, my email is always available. Feel free to ask me some questions. I'm happy to help you with the homework. It's not like, oh, you have to do it yourself. It's a test and you can't ask anyone. No, like I'm happy to help with it if you need it. With that though, I do want to take a look at the homework. So this week's a little bit different. I will share a solution of my own, but hopefully in the future weeks, I'll pick someone who has an answer that I like, and I'll share that instead. But if we can see my screen now. So this is Google Colab, my kind of homework answer that I wrote, although it's slightly different than the instructions, but we'll step through it. So it begins with a while true, and then we have the thing that we talked about last week, try except. So I have my try block, and I have some lines of code there. I have my except block for value errors, and I have my except block for zero division errors. And so the main part of this program I wanted is to ask the user for two numbers and take the first number, divide it by the second number. And this could have a couple errors. Maybe the user doesn't type in numbers. Maybe the user wants to divide by 0, which isn't allowed. And so in both of those cases, you will get an exception or an error in Python. And without try except, the program would just crash, right? It would just break. You can't continue, you can't recover. However, we learned last week, using try except, there are ways that you can build into your program to recover from errors. In this case, you'll see the way we kind of recover is we just ask the user again. And so let me just run what I have. It'll prompt me enter the first number. First time, let's just do something that makes sense. Let's do 9 divided by 3. So first number is 9, second number is 3. It prints out 3, right? No surprise there. However, I can show you that it does protect against errors, right? So say I say 9, and then the second time I do 0. If this happens, it'll just say, oops, you can't divide by 0, right? Instead of crashing, instead of saying 0 division error, blah, 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 can't continue, it asks me again. So it's like, okay, it didn't work the first time. Let's try again. So let's do 8 and 0 again. Still handles it, right? That's still 0 division error, still handles it. Everything's fine. It also does handle if you type in text, right? So if I type like 5 and then Jack, it says, oops, please enter a number. And then it'll ask me again. So this time if I type it in first, it also catches it. Then to finish it, let's just do something that makes sense again. 6 divided by 2 is 3. Right. So that's kind of the program running. You can see it's handling the errors right there in the message. I do have a couple questions I want to ask because this is something I wrote and not from you guys. So I want to make sure it's you understand what's going on here. So I'm not going to go in the order top to bottom, but let's just begin with this one. So I have two except blocks or statements. The first one is for value errors. The second one is for zero division errors. So my first question is, does this order matter in this case, right? So if I happen to swap the value error with the zero division error, right? If I move those two lines of code around, does my program still work? Does it still do what I want it to do? Or will there be a problem here? So I see a chat message. So Andrew says yes. So can you tell me why you say yes? Why does the order matter? I know that's a little bit of longer answer, so I'll give you a little bit of time to type. In the meantime, I have the other questions on the screen, so if you want to think about answers to the other questions, feel free to start thinking about it. Okay, so for this question, I'm just gonna say it's yes, but no. So I would say the answer to this question specifically is no. The order does not matter. But that's not the case in general. And so I think that's why, Andrew, you said yes. Last class, we did talk about how the order of accept statements does matter in general. So in general, if you're writing try excepts, you have to be careful about the order because sometimes the order will change how it works. If you mess around the order, it'll do things that you don't want it to do. In this case, it doesn't matter. The reason why it doesn't matter in this specific case, in this specific program, is because value errors and zero division errors, they're kind of two different categories of errors. And so whether you handle one first or the handle one second, it doesn't really matter because there's no overlap happening. As long as there's no overlap, the order doesn't matter, right? This is actually kind of the same as when we did if else statements, the conditionals. The order of conditionals kind of matters, right? So if you have an if, else if, else if, else if, else, it just does the first one that is satisfied, right? And so if you have a more general case at the front, it's just going to do that and it's going to ignore everything after, right? That's the exact same thing with these excepts. If you have something more general that overlaps with things below it, that will cause problems. In this case, they don't overlap, so no problems about switching. Right? So kind of related to this, kind of the same concept, but a little bit different. The second question I want to ask. Here I'm doing except zero division error because obviously I want to catch if someone types in divide by zero, right? My question is, if I change this instead of zero division error, I change it to arithmetic error, a different type of error. So I like replace this with arithmetic error. Would this work, right? What does my program still function how I want it to? Does it still handle the zero division error? Or will this now break if I type in 9 divided by 0? Andrew says yes again. Let's just get a couple answers this time. So yes or no in the chat. If you think yes, it works, or no, it doesn't work. I changed the zero division error to an arithmetic error. Jonathan says not sure, probably though. Perfectly fine to be not sure. We're here to learn, so that's not a problem. So we have yes with a question mark and probably. So looks like the consensus is kind of iffy, but leaning towards yes. And so the answer to this is yes. So you're correct, Andrew and Jonathan. This does work. And so this is kind of the same concept as before. There's an overlap here. Arithmetic errors and zero division errors overlap. Specifically, zero division errors are just a subsection of arithmetic errors, right? You can make a variety of arithmetic errors. Arithmetic if you don't know, is just math errors, basically. So zero division error is just one type of arithmetic error. So if you're catching zero division errors and you switch it to catching arithmetic errors, you're just catching something more broad. So everything that the previous program did, this will also do, and it will do more. I would say this is probably the better one, the zero division error, just because you want to be as specific as you can in general. Yeah. Then finally, the last question I have is kind of these two parts. Why do we have the while true loop? And because of the while loop, why do we break here? Right? These kind of go together, right? If we didn't have the while true, we wouldn't need the break. So why do we put a break there? And why do we have a while true? What's the purpose of this in terms of how the program works, as you can see here? I guess one way to ask it is if I remove this line, right? If I remove the loop, I remove the break, this program works by itself. But it does something a little bit different than when we have the loop and we have the break. We saw this in an example last class, I believe, where you have this while true with the try except. And I'd say this is, it's not like super common, but it is like a use of while true and try excepts that you'll see now and then. It does show up because it's pretty useful. So Andrew says, if we don't have the loop, we can't ask the program to give user a second time to input when they input wrong the first time. So that's exactly right. The while true loop and the break, they're going together because we kind of want to give the user another try and another try and another try and another try, right? We're kind of forgiving. If they don't do the right thing the first time, we ask again. And so that's the purpose of the while loop, right? The while loop lets us do it again. If you notice while true, specifically, that's an infinite loop, right? If we don't do anything, while true just runs forever. It just will do whatever's inside for the rest of time. Right? And so that's why we have the break, to stop it. And the question is, when do we stop it? Well, we stop it when the user inputs something correct, right? We don't want to ask again if the user already did what we wanted. And so we put the break at the end of the try statement or the try block. That's because if we reach this point, this means none of these lines above had any problems. Because if they had any problems, we would have gone into these, into the excepts, right? But because we didn't have any problems, we put it into the break here. We put it at the break end. We've reached here, we're done. We can stop the loop, right? And so if we had breaks here, can anyone tell me what would happen here, right? So I purposely did not put breaks in the except statements, right? Why do we not break in the except statements? That's a kind of a follow-up question to this. Right? So we have the break with the try, but why don't we put the breaks in all of the statements? Why don't we put it in the excepts as well? Yeah, that's correct, Andrew. So if we put the breaks in the excepts, what would happen is, well, the breaking is stopping the loop, right? So if we break, we don't ask the user again. So let's think about what's happening here. We're in the except, which means something wrong happened, right? The user typed in something they shouldn't have. And then we break. That means we stop. That means we don't ask the user a second time. So that's why we don't want the breaks here. We don't want to stop when an error happens, right? We want to continue. We want to keep looping when an error happens. And so that's why we don't have the breaks here. And so that's good. the last part of the homework that I didn't include here, that was in the instructions, was I wanted an else and a finally statement. So the while loop was not actually part of the assignment. If you didn't have the while loop, perfectly fine. That wasn't required. But I thought it was interesting, and I saw someone using it, so I thought I'd show it as well. But back to the slides and the last two review questions from last week is just about the else and finally. So these are like one sentence answers. I don't need a lot. Just very simply, first, what does the else clause do? Or in another way to say it is like, when does the else clause run? Right? So I can put an else here. I can put an else print hi, right? But when is this run? When does the else clause run? What does it do? What is its purpose in the try except? All right, I think the easier one is finally, because the name of it is kind of a clue of what it does. So maybe we can do finally first. Like, when does the finally statement run? Does it happen first? Does it happen last? Does it always happen, or does it happen some of the times? So finally goes at the end and is put once the code is run correctly, I think. It runs at last without error. So yes, so the correct, it goes at the end, not just it runs at the end, but you do have it at the end of the try except whole thing. Like you should put finally at the end. You shouldn't put finally before except. The part where I think you're getting it confused, you say if it runs correctly without error, that's the else, right? So the else is exactly what you were saying. It runs if the code didn't have any errors, right? So technically, in this case, we could have put the break in the else. Maybe that makes more sense. Right? So here, this actually makes a little bit more sense. We put the break in the else statement because if we've reached the else statement, that means no errors happened. Right? If no errors happen, we want to stop. Right? And so this runs if no errors from try. Right? So if we do the try, we finish, there's no errors, then we do the else. If there are exceptions, if we catch any errors, then this is not run. Right? So it's conditional. Finally, on the other hand, is also at the end, if does it after the try is done, but it always runs, whether you have an error, whether you don't have an error, whether the error was handled or the error was not handled, right? Does not matter what happened. As long as your computer is on, as long as you didn't turn off the power, the finally will run, right? So that's the important thing to remember. Finally always runs, else runs some of the time, specifically when there are no errors. Okay. So that's pretty much everything we covered last week. Basically just error handling. This material isn't going to be built onto directly. So we're not going to do like advanced try catch later on. But from this point on, I would say like as a standard for homework assignments or code that we're going to do, try to make your code so that it can never crash, right? Try to handle all exceptions that will happen in your code, because I'm going to give you assignments and there are going to be invalid inputs some of the time. Good practice is to make sure that your code always can deal with it, right? You never want your code to crash. Right? That's never a good thing. Well, unless you're doing something really weird. But like in general, you never want your code to crash, right? So because we learned try catch, try except, in the future, you want to try to make sure your errors are handled. That's what I had for the homework and review for last class, although I know going over the questions was a little bit difficult. So I really want to make sure if anyone has any questions about try except about what I did here on the homework, please leave a message or speak up. Jerry asks, so does finally cover everything other than the excepts and the else? No. So finally will be run alongside the other ones. So else is exclusive, right? So you either do the except or you do the else, right? You do one or the other. Finally, on the other hand, is always run, right? So you can do the except and you can do the finally. You can do the else and you can do the finally, right? So it's not like, oh, if none of the above didn't work, do this. It's always do it. Doesn't matter what happened above. Does that answer your question, Jerry? Cool. So I've gotten a lot of answers from Jonathan and Andrew. Jerry asked a question. Alex, Jennifer, Jason, do you have any questions about try except? This idea of handling errors. Awesome, Jennifer. Alex or Jason, can you unmute or put in chat? You can say you have no questions, or you can put in questions that you have. The benefit for me, but maybe a curse for you guys, of a small class is that this allows me to kind of make sure everyone is included, and I don't want to leave anyone behind. So I'm gonna start, if people aren't participating, I want to make sure that they're following along still. Like, I can understand if you're not comfortable talking that much, and I know I'm usually more of a shy person. I don't like talking, speaking out. And it's perfectly fine if you're following along and understanding everything. I don't mind that really, but I just want to make sure that we're not leaving people behind. Let me check. Okay, yeah. So Alex or Jason, do you have any questions before we move on to some new material for today? Thanks, Alex. Jason, do you have any questions? Awesome. If any questions do show up, I should clarify. I said awesome, not because there were no questions, not because I'm bothered by questions. I'm just glad people feel comfortable. But if you do have questions, I don't mind slowing down. Well, that's another point. Even if you don't have questions, but you feel like the pace is a little bit too fast, I'm definitely happy to slow down. I have a general lesson plan, but it's not like, oh, I need to finish this today, or I need to finish this for the course. It's just wherever we can get to, we cover. Whatever we don't will be left for the future. So if the pace is too fast, please also speak up as well. For today, we're covering a new topic and something that's a little bit familiar, but hopefully by the end of this, you'll see it's something really, really useful, because this is definitely super, super useful, and you're going to use this all the time after this. But to begin, we're going to talk about Python functions. So that's the topic for today, but we're going to begin with kind of why do we care, right? Like, why does it matter, right? So I have kind of like a sample problem. In the interest of time, I'll just talk over it for now. We have kind of a problem that someone gave us, right? We have two variables, x and y, and we want to give a third variable, z, some value, depending on what x and y are, right? So if x is greater than y, z should be the sum. So I want to add up x and y and store it into z. On the other hand, if x is not greater than y, then we want to find the difference and store that into z, right? So z's value depends on x and y. So in the first case, if x is 10, y is 6, then x is greater than y, so we add it up, z is 16. In the second case, x is 6, y is 10. Now x is not greater than y. So we want to do the difference, 10 minus 6, and store forward into z. So I hope it's a little bit clear what's going on. It's a little bit arbitrary, but you can definitely imagine this being like a real thing. For example, you're programming a game, and maybe the level has a threshold, like you need to get 500 points before you can continue. And so you want to check, is x greater than 500? If so, continue. If not, do something else, right? If we were to code this right now, we just do like a if statement. Simple as that, right? We have two variables, x and y. If x is greater than y, z equals x plus y, else z equals y minus x. Right? Pretty simple, pretty much what we've seen before. Nothing new so far, right? The thing that we shouldn't like about this program is that we one, have specific values for x and y. So we say x equals 10, y equals 6. Because, well, we're not always going to have access to this in the real world, right? You might not know what x and y are in the first place ahead of time. Because imagine that if you were able to know these ahead of time, right? When you were writing the program, you already know what x and y are. Then what's the point of the if statement? You already know what the result is going to be, right? This example is kind of dumb in the real world, right? Another way this is bad is because we can imagine this kind of functionality. If x is greater than y, do this, else do something else. This is something that we might need in a lot of different places in our program, right? This is just one kind of building block that we're going to use in multiple different places. And so from what we know so far, what we just do is just copy paste the whatever 4 about lines of code. We can just copy this into wherever we need it. But this isn't very good because one philosophy in programming and one that you should try to embrace is called dry programming, or DRY, dry, which stands for don't repeat yourself. So you never want to copy paste code multiple times in your program. You don't want to repeat yourself. The reason for this is what happens if you find a bug in your code that you copy pasted? Well, now maybe the fix is simple, but now you have to remember every single place that you copied your code and go there and fix the bug there as well, right? Because you copied the bug into 5 different places, into 10 different places, into 100 different places. Now you have to go back and change every one of those places. That's just not very smart, right? So how can we do this in a better way? That's what Python functions is all about. So that's what we talked about. Python functions is just a block of code intended to achieve a specific task. It can be a small task, it can be a large task. Usually, a function will return a value that the caller can use, but this isn't always required. And we'll go over examples that you do return and you don't return. In terms of how you write this in Python, you use the specific def keyword. So def, short for define. This is the special keyword that we're going to use when we write functions. This is the same as like if is a special keyword. Try is a special keyword. So it's just a signal to Python that we're writing a function. After the def, we have the name of the function and then a list of parameters. And we'll go over examples. Again, why do we care before we look at actual code? It just breaks large tasks down into smaller sections. That makes things more organized, right? You can take a big task, split it up into small tasks, and then write a function for each of the small tasks. So instead of a code that's like 500 lines of code, you can break it up into 5 100-line functions. And that way, you can look at each block and you can give it to other people to look at, and they can just focus on that 100 line of code instead of the whole 500, right? It just makes things easier for people when they work together. And like I said, eliminates repetition, which which is exactly what we don't want. We don't want to repeat ourselves. We never want to copy paste code again and again. So onto some examples. The slide has some, but I'm gonna start writing my own. Here I have a Colab notebook. So if you can open up PyCharm, any Python editor, Google Colab, anything that you want to use to write Python is fine with me. But please open that up now if you haven't already, because we're going to start writing some Python functions. So the simplest function that you can write, right? Let's begin there. You want to say def because that's the special keyword. Right? You need to say def to show Python you're creating a function. So I say def, then I put a space because that's separate. From the slides, what goes here is now the function name. So this can be anything you want. You can name your function whatever you want, as long as it's a valid name in Python. So anything that you can name a variable, you can also name a function. So the same rules apply. You can't have spaces in your name. You can't have special symbols in your name. You can have underscores. That's like the one special symbol that you can have, but you can't start with a number. Like you can't do that. You can't say def for whatever. You can't start with a number. So I'm just gonna call it first func, for example. Or in Python, typically you put an underscore where you would normally have a space to separate words. After the name of the function comes a list of your parameters or inputs to the function. But since we're doing the simplest function first, let's just not take in any inputs. Let's not worry about it. So we put parentheses. So again, this is almost done for our first line. Def space the name of your function. So here it's called first func. Parentheses with your inputs to the function inside. Here, we don't have anything inside. We don't have any inputs, but you still need the parentheses. You always need the parentheses. Finally, since we're writing a function, which is a block of code, we need the colon. If you remember from before, the colon tells Python, okay, the next lines following this is a block of code. It belongs together. I need to keep this together. And so that's why you need the colon. If you don't have the colon, it doesn't know what's going on. It doesn't know if the next line is part of the function or the next 100 lines are. You really need the colon. Along with the colon, everything inside the function needs to be indented. So just this is the exact same thing as like a try statement, an if statement. You need the colon and you need indents to show your block of code. But this by itself is defining a function. We have to tell what the function is doing. So simplest function, let's just print hi, right? Simple function. So this 2 lines of code is basically the simplest function that you can write. Def is common with any function that you write. You have the name of your function. You have your inputs. In this case, you have none. Colon, indent, and then whatever is inside your function, whatever it does. In this case, this function, first func, prints hi. That's all it does, right? And so now I can run this cell, and you'll notice once it starts loading, it ran, right? There's a number 1. The cell ran, but nothing happened, right? There was no printing of highs, right? I don't see hi being printed anywhere. Right? And that's expected, right? So these 2 lines of code does not print hi. What these 2 lines of code do is define a function. It's kind of like a shorthand, right? So it only defines it. It doesn't run it, right? So how do we run the function? How do we actually use it? Well, once we write it, all we do is just type the function name. So here, first func, and then we need the parentheses again. So here, if there were any inputs to your function, you'd put it in the parentheses. But since we have none, we just leave it blank. And then we can just run it. Notice there's no colon because we don't have any code in a block after it. But here you can see I run first func and it prints hi. I can break the dry principle and repeat myself a couple of times. And you can see it prints hi a couple of times, right? Shouldn't be very exciting, right? Honestly, this is more code than if we just said print hi 4 times, right? Here we need 2 extra lines of code to define this function. Why would we ever do that, right? Well, your function doesn't have to be just 1 line, right? You could, maybe your function is for I in range 5, print hi. So now my function prints hi 5 times, right? I define it, it doesn't do anything. I run it and it prints hi 5 times. Now if I call my function a couple of times, now it'll print hi a lot, right? And so now you can see, kind of useful, I guess. Another way this is useful, instead of just using this directly, is, well, now if you need this in different cells of your program, if you have like a 1,000 line program and you need to do this in 10 different places, well, now you can just call this function wherever you need it. You just say first func with parentheses, wherever you need to do this. Right? So let's just make it simple again. Print hi. Most basic function. Taking it one step higher, we can add an input to this function, right? So this function right now doesn't take in anything. It always does the same thing every single time, right? To change that, we need to put something in the parentheses here, in the definition, right? So we're going to define our function instead of taking in nothing. We want to define it so it takes in maybe a message. So I just say message here. This is like a variable name. And now inside the function, inside the colon block, we can use that variable just like any other variable. And so now instead of printing hi, I can say print message, right? Or to make this unique, I guess, I can print it 3 times. So for I in range 3, print the message, right? So this function now takes in a message and prints it 3 times, right? It's still not super exciting, but it's one step more than before. And so to show that this is working, I can run this. And again, running this cell, running these 3 lines of code doesn't produce any output because this is defining the function. Defining it and using it are different. You have to define it first, right? You can't use it without defining it. Then Python's like, I don't know what you're talking about. I don't know what this function that you're talking about is doing, right? So you have to define it first, but it doesn't actually do anything until you call it, until you use it. And so now I say first func because that's the name of my function. But now, since I defined it to take in a message, now instead of just doing parentheses with nothing, I need to put something in here, right? So what's a good message? I can say like, hi class. And so now I can do this. Oh, here I don't want to print the string message. I want to print the variable message. And here, now prints it 3 times for me, right? So now I can change this to whatever I want. Right? Say Bob, and it'll print Bob 3 times. I can say ASDF, and I'll print ASDF 3 times, right? So now this first func is kind of like a shorthand for printing something 3 times, right? That's a little bit cool, right? I mean, it's not super useful, but you can see how to expand this to do a lot more things, a lot more powerful things. For example, another way you could root this, let me write another function. I can say like a greeting function. So def greeting. And maybe this greeting function takes in a name. And what this function does is it says print hi, and then let me put a space there, and plus name, right? So this, if I shift enter, now I can say greeting Jack, right? And if I do this, I'll say hi Jack. I can do, just looking at the Zoom, Jonathan, and it'll say hi Jonathan, right? So again, these are very simple functions. They're not too exciting, but they're starting to get there, right? You don't have to stop here. A function doesn't have to take in one thing. It can take in as many as you want. So maybe I take in a name 1 and a name 2, right? And so now it'll say hi name 1, and it'll say by name 2, right? Does something different for each one, right? And so now I have to give it 2 names. I can say Jonathan and looking at Zoom chat again, Andrew. So now it says hi Jonathan, and it says bye Andrew, right? You can expand this to 10 names if you wanted. Wouldn't really recommend it, but you can, right? So that's kind of one category of functions, the simplest functions. Here is a function, well, I deleted it. A function that takes in nothing is what we saw at first. And now we started dealing with functions that do take in inputs, right? So you can take in 1 input, you can take in 2 inputs. A quick question. If now I want to change the definition of my function. So now, instead of calling it name 1 and name 2, I want to call it name A and name B, right? Simple change to the definition. I have a question. Where else do I need to change things now? Right, so it used to be name 1, name 2. Now it's name A, name B. What other lines of code do I need to change? Do I need to change these 2 lines of code? Do I need to change how I use the function? Right. So which lines should I touch and which lines are fine how they are? So change the name 1, name 2, and print. Yep, I agree. These don't exist anymore. These should be name A, name B. Do I need to change these? Right. They used to be name 1, name 2. Now they're name A, name B. Yep. These are perfectly fine, right? These are connected to these variables, but they're not the same thing, right? You can think of what happens is it takes in these values and stores it into these variables. So all we did is change the name of the variable. We don't have to change the value of it to match, right? That doesn't make sense at all. The values can be what they were originally. But if you change the definition of what the inputs are, you have to change what happens inside the function, right? You have to use these variables. I hope that's a little bit clear. Yeah. So here, let me just check the time, 6:44. Okay, plenty of time. From here is just talking about more features that you can do with functions. And so there's 2 main ones I want to cover today, which we should have time for. So before we get there though, this is the example from the slide. It uses a format function in itself, which I didn't really like. That's why I didn't really cover it. But this is just taking in 2 values, adding it up, and calculating the sum. And so we can define it, and we can run it. Right. This does bring up one point I want to talk about. I don't think any of you guys came from Java or other programming languages before this that have typing. But in Python, all variables can store anything, right? If you create a variable x, it can store a number, it can store a string, it can store a list, it can store whatever you want, right? So when you write a function that takes in x and y, there's nothing stopping someone from putting in whatever values that they want, right? X can be whatever value the user wants it to be. Y can be whatever value the user wants it to be. So here we can use this function to add 5 and 6 integers. We can use it to add decimal values, 12.5. We can also use it to add strings. You can even use this to add lists. You can use the plus to join two lists together. I can show that to you. Some problem. Right, so list 1 would be like A, B, C, and then list 2 could be the list like 1, 2, 3. And so the sum of A, B, C and 1, 2, 3 is the list of them combined, right? So this is something that is powerful, but also something you should watch out for, right? Maybe you're writing this function and, okay, it's adding two things. Of course, it's going to be numbers, right? I'm going to just use the plus sign, add them together, print out the result. Everything's fine, right? Yeah, sure, that works. But if someone happens to put something that's not a number, there might be a problem, right? I mean, it works, but maybe you don't want it to handle non-numbers, right? Just something to watch out for, something that's interesting, I think. Because also like what it does is a little bit different. If you pass in numbers, it does arithmetic, it does math. If you pass in strings or a list, it does concatenation, it combines them together. The next feature though, that I want to talk about, the new thing, is a return value. And so going back to the slides, this. So here's a function that does some things that we aren't familiar with. We don't know what the set thing is, but the important thing is this return statement at the end. So you can just think of these lines of code do something. Specifically, it finds the common characters in two different strings. But the key thing is it returns a value, right? That's the new thing that we haven't seen so far. What is this return statement? So if you write a function that returns something, right? How you're going to use the function now changes a little bit, right? Before, all these functions didn't return anything. You just call the function directly, right? You just call some problem 5, 6, and it does these 3 lines of code, and it prints it out, and you're done, right? It does what it tells you to do, and you're done, right? When you have a function that returns a value, like this getCommon function, you're going to call the function, but now you want to store the result somewhere because this function returns a value. It does what you want it to do, and then it gives a value back. Well, if it gives you a value back, you have to store it somewhere, right? So here we're storing it into the variable z. Z equals the result of this function. Right? You can think of it as like this function is a friend, and you're like, hey, do this thing for me and come back with the result later, right? So the friend takes what the inputs are, it does whatever calculation you want it to do, and then it says, okay, hey, the answer that you want is blah, 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 right? So it gives you a result, you need to store it. If you don't store it, it's kind of lost, right? But yeah, you call the function, you store it into a variable, and then from there on, you just use the variable just like anything else. So in the notebook, I can copy paste this into Zoom chat, but this is the getCommon function. Again, how it works, not super important, but how you use it does. So here, I want to define it. And then here's me using it. So getCommon, write code, drink water. Oh, I think someone's knocking. Let me, really sorry. I'm gonna step out for a minute. All right, sorry about that. I'm back. I think someone's just doing construction outside, and I thought someone was knocking on the door. But here it gives me the common letters, and then we store it into this variable ASDF and we print it out. Right? You could call this result and print result instead. So that's a function that returns a value. Right? For example, if we change one of these functions, say, let's do the greeting function, but let's just go back to one name where it says hi. Let's, instead of printing it out, let's just say like x equals hi plus name A and return x, right? And so now if I do greeting Jonathan again, this technically still runs. The reason is Colab automatically prints it out. But here we can say like, again, like y equals this. And now if you want to do any string functions like, I don't know, y dot split, it's just a string that you can work with however you want. Right? I can print it or I can do other things like upper. Oops. Okay. Hi, Jonathan, yelling at it now. Right. So that's the difference between returning and not returning. You should, when you're writing the function, you should know if it needs to return or not. It really just depends on what you need it for. Maybe you need to pass the value on to somewhere else. There you need to return it. If instead you're just doing some sort of calculation and you just care about showing the result or whatever, storing a value, modifying something, then no need to return. You just print it out and you're done, right? So that's return. Technically, a little bit advanced, technically you can return multiple values. So you don't, here we're returning Z, but we could return multiple things. That's a little bit advanced. Might come back to that later, but if you ever need to do that in the future, that is a possibility. Right. I have an exercise, not going to do that. But what we are going to do is this default variables, default values thing. And so let's just go back to my function, greeting, because I think it's easier if we just keep using the same thing and modifying it a little bit. So the last extra thing that we're going to cover in today's class is default values, which means that if we're lazy and we don't want to pass in a value, then it will just supply one automatically, right? And so here we have this greeting function. It takes in an input name A, and it returns hi plus name A. It just adds hi in front of it, right? Well, what if we're lazy and we don't always want to provide a name of our own? What if we want some sort of default name for this function? So here, to provide a default value, basically a value that is there if the user doesn't supply one themselves. You just say, after the name of the variable, you just say equals, and then whatever value you want it to be. And normally you wouldn't have the spaces, so I'm not going to put the spaces, but like maybe by default it's unknown, right? And so if we run this and run what we had before, it doesn't do anything special, right? It still works exactly like how we want it to work. You put in a name here and it just returns a string, and here I'm printing y.upper. So we turn it to uppercase and print it out. Nothing exciting here. The difference now, though, is because we have a default value, you don't have to give an input if you don't want, right? I'm fine just doing no inputs, right? I can say y.greeting, and now I'll just say hi unknown, right? We didn't pass in a name. Right? So now this function works with either 1 or 0 inputs, right? If you give it an input, it'll just replace unknown with whatever value you want it to be. If you don't give it an input, it'll just use the default value, right? Simple as that. This is not as of an interesting example because there's not much use of having a default value here. Where a default value is more common is, say you have a function that's like a plotting function, right? In Python, there's a lot of ways to create graphs. You have some data, you want to plot it on the screen. You're going to have a lot of default values in that case, because a lot of times people are just going to supply like the X and Y values of your data points. Right? You have your X and Y data values, you want to plot it on the screen, simple as that. But maybe some people want to change the color of the plots, the color of the dots. So you might have that as an input to your function. But you don't want the user to always have to supply it because sometimes they don't care, right? So you're going to have a default value for the color. You're probably going to have a default value for the size, right? Most people probably don't care about how big the circles are, but you do want the ability to change it if possible, right? Default values are also used when like 90% of the time you're going to have one specific case, but then 10% of the time it might be different. In that case, you just set the default value to the 90% case so that when you're using the function, you don't have to keep typing the same input every single time. Yeah, so that's the material for today. Going back to the slides, I know there's some things I didn't cover yet, but probably we'll do that next week. What I do want to cover is the homework for next week. So this homework is actually kind of a two-parter. The first one is easier. The second one is not difficult, but just a little bit tricky. There's some things that you have to watch out for. But the first one is kind of has a story along with it. So suppose you're working with a company and you need to pay the contractors, the workers. So you're the HR, which is the person who is responsible, the department that's responsible for paying everyone. And we need a function, a Python function, to calculate how much to pay each contractor, each worker. And so this function should take in the contractor's hourly rate, how much they work, how much they make every hour, and how many hours they worked, right? You need to know those two values to pay a person. However, sometimes the hourly rate might not be available. Maybe you don't have it on hand. In that case, you want to use the default value of $11 per hour. So the default, you have a default value in this case. So given that, you need to write a function to basically calculate how much to pay someone. It will take in two things. One that's required is the hours worked. That's required, always going to be supplied. The second that's optional is the hourly rate. If it's not supplied, you want to use the default of 11. Inside the function, all you need to do is calculate how much it should be paid and return the result. Right, simple as that. Should be pretty straightforward and similar to one of the things I showed today in class. The part two, which I do want everyone to try, it's a little bit tricky, but it's not going to be over your heads. You should be able to do it. Here, we're writing a different function. You're given a list of random integers as input. So when I say random, that means they're not sorted, right? The order of the integers is random, right? You can't assume anything. Given this list of integers, I want you to return the median value, which means the value in the middle, right? So this should be from math class. The median is just half the numbers are larger, half the numbers are smaller, right? And so I just want a function that does that. It takes in a list of numbers and returns the median. Right? The tricky thing is the list that you're given is random. So you need to figure out a way how to find the median that way. And I have a hint there. You want to sort the list and think about how sorting the list is going to be useful. If you need a refresher of how to sort lists in Python, the slides are from level 1 if you have access to them. If not, I can post or I can write up the sort method, but that's also available online, sorting list. That's it for the instructions. I would say in terms of how you want to submit this, again, it's submit the code or screenshots, but I definitely want to see evidence of you checking to make sure that your function works, right? Because like I said before, when you're writing functions, when you just write the function, it doesn't do anything. It defines it, but you can define a function that doesn't work, right? So I want you to define the function, and then I want you to use it on a couple different sample inputs. So these should be inputs that you come up with. You want to test your program, make sure it works, right? So I want you to come up with a couple test cases for these problems. So come up with a couple random lists of integers and make sure it returns the median. Come up with a couple different rates and hours worked and make sure it calculates the right value, right? So I want to see some evidence, like I want to use in the code to try to run it and look at the output, make sure it matches what you want it to be. But yeah, that's all I had for the content for today. And I know we should be 7:02. I went over a little bit again. Sorry for that. If you have any questions, I'll be sticking around and be happy to answer them. If not, have a great week. Please try to get the homework done a day before class. So probably by the end of the weekend that's coming up. That's all I have. Thank you for sticking.